Hello everyone, welcome to my channel. I'm Miga and today we'll be talking about how to draw the two version of the chair conformation, right? The flip version. Because the professor can give us any compound and ask us to draw to the both chair conformation, right? So if you've watched my previous video, I hope you now know at least how to draw every position, how to draw a chair structure and every little position. Here, guys, this is a naked chair conformation. Like, there's no group here. Probably I could have put X. It could be any group you want. It could be hydrogen. Each X can be an hydrogen, a bromine. This is just a naked structure. Remember what I said in the previous video? Whenever you're flipping, yes, the schematic, the drawing itself is a little different, right? I show you how to do it. But another thing that differs is the place of the numbering. In both, guys, remember, stay consistent because it's a molecule. You could be holding this molecule too. So if you're gonna count your substituent in the clockwise direction, you have to make sure in both, even after the flipping, it's also clockwise. And remember what I said, whenever you're flipping, you need to start the numbering on the other version one carbon over. For example, here I started to count at this position here. I started to count at this position. 1, 2, 3, 4, clockwise. Then in the other, after the flip version, I need to start one carbon over. I'm not gonna start here. No, I'm not gonna start here. I'm gonna start counting here. 1, 2, 3, 4, 5, etc. Okay? All right, now let's get started with some practice. Let's say you are given this molecule here and the professor is asking you to draw both structure of the both chair conformation of this structure. I believe this structure is called mental. But anyway, let's do this. First, let's do OV. And matter of fact, I can do both version real quick, right? Let's do that. Like I said earlier, do something parallel here and we connect them, right? So that will be my two because I already know we have in the both case we have cyclohexane. And then let's number of carbon. So I'm gonna start this way, 1, 2, 3, 4. Again, I chose to name in the counterclockwise here. So and you know, I'm gonna stay in the same direction too. I wanna remain keep it in the counterclockwise direction. So let me start here. 1, 2, 3, 4, 5, and 6. Remember, if I'm gonna go counterclockwise, I wanna make sure I start a carbon over. 1, 2, 3, 4, 5, 6. And now let's add our substituent. First, I'm noticing that carbon 1, at carbon 1, the substituent, which is this group here, is pointing down, right? So I already know that down is actual whenever my carbon is at this position around here. So if you're not sure, you can have your schematic on the side. And I'm interested in this structure here, this first version of the structure. And at this position, I want to put it pointing down. So I'm going to put down, right? I put it actual. Look at this. Yeah, this position down is actual. And remember, on the lines, any line structure, we don't need to represent the hydrogen. We already know there's an hydrogen. Here, there should be an hydrogen pointing in the equatorial one position up, but we don't care about it. We're not gonna represent it. Okay? All right, at position 2, there's an OH group that should be pointing up. As a matter of fact, I even like to write up or down here. This is down. Let's do this real quick. This is down here. This OH group is up. This one is up. Okay. So at position 2, so according to my numbering, so here where my position 2 will be, it should be pointing up. So quickly, let me see what pointing up mean when we're talking about the carbon at this position. Oh, also actual. So let me make sure that I put something. I put my OH group in the actual position here. Put in black. Oh, let me remove that arrow for a second. The arrow is just my reference. So remember that whatever I do, I have to add my substituent and my numbering, in the counterclockwise direction. Okay, and then we're interested at position 4. This one here, they say it should be pointing up. So quickly, let me go to my reference to see where the position of up, is it actual equatorial when we're talking about this carbon in this corner here? Up should be actual. So I'm gonna make sure that I place it in the actual position up. And remember, this is a CH3. So we don't even have to write the group. We don't even have to write CH3. It's a line bond structure. You can leave it the way it is. And that's one. I think we place everything. Everything look good here. Now let's draw the other version of the flip, right? The flip version. Remember, the only thing that's gonna differ between those two versions here is where I started to number. Of course, the schematic, the little chair backbone is a little different, but I already showed you how to draw it. There's no big deal about it. But it's important, guys, that you start counting the same direction that of numbering. You start numbering it one carbon over. I will always keep saying it because some people forget about that part. Okay, so here again, we can see that on our first structure, again, you can look at this structure to do the same thing again, but for me, I like to look at this structure. If I'm sure of my drawing, why not? It's like fast. At least it's better because I know in the flip version, it's important for me because in the flip version, I want to make sure that if, for example, this group was pointing down, is the actual position, that's actual, right? Then it should be pointing down, but equatorial in my second. If everything is reversed in the sense that actual become equatorial and equatorial become actual, I know I did my structure well. So let's get started. One should be pointing down in the actual position. So here in the flip, we are at this position. We want it pointing down. Let's see what this version here, this version we're here now. Let's see what this version look like when we're at this position, pointing down. Oh, it's green. We can see that it's gonna be equatorial, which I want. So let me do this. We're gonna do that, right? Pointing down. Okay. Now they want number 2, this structure here. 2 will be pointing up, right? But my 2 is here in the flip version. So let's see. This is the 2. But we're gonna be around here, still equatorial, which I like because before I had an actual. Now we're gonna transition to equatorial. Let's do this. And then we wanna go to 4, carbon 4. Here we're sorting up, 4, up in this version. So we're gonna be here 4, but we want it to point up. So let's quickly analyze the little schematic or representation, especially this one. So we're interested in this one. 4, but we want it up. So 4 at this position up is also equatorial, which is correct. 4, we will put, oh, not the best drawing, but hey. And that's it. As you can see, I place on my group and I can see right there that everything should be fine here because before I have 3 groups that were in the actual position and now all 3 are in the equatorial. Now let's clean here a little. There's too much color. Now, if the professor asks you to circle the structure that is the most stable, remember guys, the more structure we have in the equatorial position, the better. So right there, I can tell that this structure on the right is the most stable structure because we have all 3 groups in the equatorial position. Is another practice. Let's say the professor asks you to draw the other version of this ring flip. Quickly draw the other missing version of the chair, right? The other one, you think the flip version, okay? And then you can quickly number. Again, you don't have to follow the IUPAC rule here to name. For me, it's short. I like to stick to it, but you don't have to. You could have chosen to number your carbon in the clockwise direction, but here, it's the same thing. So I'm deciding to go counterclockwise. So I'm gonna follow the same thing, counterclockwise. clockwise direction, right? And then we're gonna quickly add a group. Remember, wherever you start, you're gonna have to start one carbon over in the same direction in the flip version. So if you started here in one, you're gonna make sure you start here. 1, 2, 3, 4. I only need the 4 group, but you can number everything if you want. And then let's quickly add the group, the substituent. One should be pointing down. So we will make sure we can draw one pointing down, right? And note how we indeed switch from axial to equatorial. So it's good and both are pointing down. 3, we have something on 3. A substituent on 3 is pointing up. I know at this position, it should be an axial group. And 4 should be pointing up. So I know here we have an equatorial. Again, quickly check yourself, axial. Oh, yeah. Axial, we switch to equatorial. Carbon 3 up, buffer up. We add equatorial to axial. That's a good transition. And here we buffer up, and we went from axial to equatorial. I know I drew it correctly. Now, let's say if the professor asks you which one of these are the most stable, again, I like to compare which group, which shell structure has the most substituent in the equatorial position. Here we have 2 axial, 1 equatorial, right? Here we have 2 equatorial. 2 equatorial, I already know that this one is gonna win. So let's say this one will be the most stable compound, okay? Again, it's not always okay. Sometimes the first version the professor gives you is the best, okay? So it's all about comparing those two, all right? And that's all I have for you guys. Thank you for watching the video. And remember, keep practicing until you get comfortable with the material so that we can move on to the next topic together. Okay? See you again on the next video.